Welcome to my algebra class. We're on chapter 10, section 1. We're going to be working with order of real numbers and graphing. Order, we consider one number less than a number if it lies to the left of it, and greater than if it lies to the right of another number. So in this case, negative 5 is less than negative 3 because it lies to the left of it on the number line. Negative 13 is greater than negative 24 because it lies to the right. The inequality symbols are going to be used. Less than points to the left, greater than points to the right. If it has a bar underneath, it's less than or equal to, or greater than or equal to. If you see a problem with two less than signs and a variable in between, it's read as a between problem. X is greater than negative 4 and x is less than 2. So it's the numbers between negative 4 and 2, and depending on whether the bar is there, we either include them or we do not. Solutions to inequalities are generally more than one possible answer. So here we have y plus 5 is less than or equal to 7 if y is a member of the set containing negative 1, 0, 1, 2, 3, 4. So we actually have negative 1 would work, that would give us 4. 0 would work. 1 would work, that would give us 6. 2 would work because that makes it less than or equal to 7, but 3 would make 8, which is too big. So our solution turned out to be 4 numbers. When we graph inequalities, the graph depends on the type of number that we're working with. So if I am working with integers, which are whole amounts, the numbers less than 6 that solve that inequality would start at 5, 4, 3, 2, 1. We'd put a dot at each of these and then a solid arrow at the end. Of course, I wouldn't do these many numbers, but we have this number line, we'll use it. And a solid arrow means it goes on to infinity. If I wanted to graph the reals, all the real numbers less than 6, I would have to start at 7, put an open circle since I'm not including 6. Start at 6. Put an open circle at 6 since I'm not including 6, but I am including the first real number to the left of 6, which we really don't know because there's an infinite number of them. Then I use a solid line shaded to the left and an arrow at the end. Solid arrow at the end, and make that a nice solid line. So that tells me it's all the real numbers. All the decimals, all the irrationals and rationals less than 6. If I wanted to graph the integers greater than 7, I would start at 8, 9, 10, put a solid arrow at the end because there's an infinite number of integers greater than 7. The reals, I would start at 7, an open circle shaded to the right because there's an infinite number of reals starting immediately to the right of 7. Less than or equal to 3, the integers, this time I would include the 3, 2, 1, and so on. Solid arrow at the end to indicate infinity. The reals less than or equal to 3, this time I would use a solid circle to indicate I'm including 3, and then shaded to the left. Solid line shaded to the left, solid arrow. And the integers greater than or equal to negative 5, you would start at negative 5 and go to the right, all the integers to the right, including negative 5, and a solid arrow at the end. And the reals greater than or equal to negative 5, we would put a solid circle at negative 5 shaded to the right. And a solid arrow at the end. That concludes the explanation for this section. You need to have your book open to 459, paper headed. And we're doing written 1 to 38, starting with the even numbers. Number 2. Translate each statement into symbols. 2 says negative 5 is less than, put the less than symbol down, negative 3. Number 4, 6 is greater than, we need the greater than sign, or equal to, the bar underneath, 2. Number 6, 0 is greater than negative 1/2 and less than 1. So that's a between problem. 0 is greater than, this is the correct way of writing it, than 1, negative 1/2, and less than 1. In other words, it's between negative 1/2 and 1. Number 8, 5 is between negative 9 and 9. So negative 9 is less than 5, and 5 is less than 9, or 5 is between negative 9 and 9. Number 10, negative 1.5 is less than negative 1. And negative 1 is less than 2, another between problem. So those are 3 ways you can state a between problem. Number 12, the number n less than 20. N less than 20. 14, the absolute value of n, absolute value symbols are 2 bars, is less than or equal to, less than with the bar underneath, n. Classify the following as true or false. 16. 0 is less than or equal to the absolute value of negative 2. We'll work that out. The absolute value of negative 2 is 2. Is 0 less than or equal to 2? It is. So it's a true statement. Number 18. The absolute value of negative 0.5 is less than or equal to negative 0.5. The absolute value of negative 0.5 is a positive 0.5. Absolute value is always positive. And is it less than negative 0.5? No, it's greater than. It lies to the right. So this is false. 20. Negative 6 is less than 1, and 1 is less than 7. That's true. 22. Negative 5 is less than negative 4, and negative 4 is less than 4. That's true. For the next set of problems, solve each inequality if x is a member of the set containing negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So 24. 3x is greater than or equal to 6. Well, what numbers from that set, when I times them by 3, would be greater than 6? None of the negative numbers would work. 0 would not work. 1 would not work. 2 would work, because that would make it equal to 6. 3 would work, that's 9, and 4 would work. So 2, 3, and 4. Number 26. We have x plus 2 is less than 3. So checking each number, negative 4 would work. That would make it less than 3. Negative 3 would work. Negative 2 would work. Negative 1 would work. 0 would make it less than 3. 1 would make it equal to 3, so we'd have to stop at 0. Number 28, 1 minus x is greater than or equal to 0. Well, 1 minus a negative 4 would be 1 plus 4, which would be 5. That wouldn't work. 1 minus a negative 3 would be 1 plus 3. That would work. 1 plus 4 is greater than or equal to 0, so 4 works. 1 plus 3 works, that makes 4. 1 minus a negative 2, that would be 1 plus 2. That's greater than 0, so 4, 3, 2, negative 4, negative 3, negative 2 work. 1 minus a negative 1 would be 1 plus 1. That would be 2, so negative 1 works. 0, 1 minus 0 is 1. That's greater than 0, so 1 works. And 1 minus 0 is 1, and that would be greater than or equal to 0, so 0 works and 1 works. But 2 would not. 1 minus 2 would be -1. So our answer is -4, -3, -2, -1, 0, and 1. Number 30, we have x squared is less than or equal to 4. So any number squared that's less than or equal to 4 would work. So that would, -4 wouldn't work, that'd be 16. -3 squared would be +9. -2 squared would be +4, so -2 works. -1 squared is 1, that would work. 0 squared is less than 4, it's 0, so 0 works. 1 squared is 1 again, so that works. 2 squared is 4, that works, but 3 squared is 9, and 4 squared is 16, so these are the numbers that work. 32, graph each inequality over the given domain. So 32 is 2 is less than h is less than 8, and it's the positive integers. So if we make a number line, it's the positive integers, so we have 2, this is 1, put all the numbers up to 9. So h has to be greater than 2 and less than 8, and it has to be an integer and it has to be positive. So that would be 3, 4, 5, 6, and 7. Can't include 8 or 2 because there's no bars underneath there. 34 says 3 is greater than or equal to t is greater than or equal to -1. I'm going to turn that around. -1 is less than or equal to t, and t is less than or equal to 3. So it looks like our number line. Always make sure that inequalities are less thans when you want to compare them to a number line. So, and this time we have the integers. So we'll put in -2, -1, 0, 1, 2, 3, and 4. Since the bars are there, we're going to include -1, and we're also going to include the 3, and then it's all the integers between those also. 36, -2 is less than m, and m is less than 2, and it's the real numbers. So this is where we're going to use a solid line, because we have to pick up everything that exists. So we'll put down -3, -2, -1, 0, 1, 2, 3. So it went everything between -2 and 2, but we don't include the ends because there's no bars, so we have to put open circles and then shade in between. So it's all the real numbers between those two. And 38 says 4 is greater than or equal to n is greater than -5. We're going to turn that around again. -5 is less than n is less than or equal to 4. And it's the negative integers. So we'll set up our number line. And we have -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. It's just the negative integers. And it says -5 is less than n, so we don't include the -5. We can include the -4, the -3, the -2, and the -1, and that's it, because it has to be negative integers, and 0 through 4 are not those are not negative. That concludes the evens. Be sure and check the back of the book for the answers to the odds.